Welcome to Blueprint to Reality, where we dive into fascinating engineering questions. Today, we're exploring what happens when you build a perfectly symmetrical skyscraper and why symmetry isn't always as perfect as it seems. Introduction to symmetry. Symmetry is often seen as the ideal in design: balance, harmony, and beauty. A perfectly symmetrical skyscraper, one that is identical on all sides, might seem like an engineering masterpiece. But when it comes to building tall structures, symmetry brings unique challenges that aren't immediately obvious. Structural and wind load challenges. In theory, symmetry distributes loads evenly throughout the building, which can make the design seem more efficient. However, the real world is rarely as perfect as the design. For instance, wind doesn't hit a building evenly from all directions. In fact, symmetrical skyscrapers are more prone to experiencing vortex shedding, a phenomenon where wind causes oscillating forces on the building. This can create dangerous swaying or even structural fatigue over time. To counteract this, engineers often incorporate aerodynamic features like tapered shapes or wind dampers, which help reduce the impact of wind forces, even in a symmetrical design. Foundation and ground settlement. Another issue is the ground itself. Soil conditions aren't always consistent beneath the structure. Even with a symmetrical design, uneven settlement can occur over time, leading to structural imbalances or stress points in certain areas. Engineers often need to use advanced foundation techniques, such as deep piling or geotechnical monitoring, to ensure the building stays level and secure. Why symmetry isn't always practical. While a perfectly symmetrical skyscraper looks balanced, its actual use may not be. The distribution of elevators, mechanical rooms, or even office space can create internal weight imbalances. Modern skyscrapers often incorporate asymmetrical elements not just for aesthetic reasons, but also to handle practical needs like wind resistance, sunlight optimization, and internal load distribution. So, what happens when you build a perfectly symmetrical skyscraper? While it may look flawless, engineers have to navigate unique challenges, from wind forces to ground conditions, to ensure it stands tall and strong. In the end, a bit of asymmetry can make a building much more stable and efficient. Thanks for watching Blueprint to Reality. If you're intrigued by the intersection of design and engineering, be sure to like and subscribe for more exciting content.